Hello friends, here in this video we will see a problem on calculation of moment of inertia for a C-section, and for that here we have a question. A channel section, which is also called as a C-section, has the following dimensions: flanges 50 mm into 10 mm, overall depth 200 mm and thickness of web as 10 mm. Find Ixx and Iyy. So this is the question we have. So whatever is given here, I'll write that in the form of data. C section. So a channel section will be like this. Here I am drawing the rough diagram for this channel section. And this channel section, it has flanges. So flanges are there at the top. This is called as top flange. Here we have bottom flange. This part is known as the web. Then the dimensions are given to us, and the question is to find Ixx and Iyy. Ixx is the moment of inertia about x-axis. Iyy is the moment of inertia about y-axis. So this is the question we have in front of us. Now when we are starting the solution, in that case, with the help of the dimensions given, we need to draw the diagram first. Let us get started. Here we have a C section. So in the solution part, here we have x and y axis. So this channel section, I'll keep it on an axis system. I'll mark the dimensions here. It is given that the flanges are 50 mm into 10 mm. So the width of the flange is 50 mm, both for bottom as well as top flange. The width will remain same, 50 mm. Then it is 50 into 10, so the width is of 10 mm. Here this I am calling it as depth, not width. This is the depth of 10 mm at top and at bottom. Then the overall depth is 200 mm. So in this case, the overall depth has been given. It is 200 mm. So it means this remaining distance is 200 minus 10 minus 10. So this becomes 180. Now, then it is given that the thickness of web is 10 mm. So here we have the web thickness as 10 mm. And the question is to calculate moment of inertia about x-axis and y-axis. So here, before we start this problem, the diagram we have drawn. Now we need to know where is the location of centroid, because until and unless we don't have the centroid, then we cannot find the moment of inertia. So we need to know the location of the centroid, and as I can look into this diagram, I can say that this C section is symmetric about the x-axis, and when it is symmetric about x-axis, in that case I know the location of this x-axis. This is half of 200, So this distance is 100 mm from bottom and even 100 mm from top. Now I can say that from this, since the given C section is symmetric about x-axis, therefore location of x-axis with respect to the location of x-axis, we are finding it with respect to the x-axis here. Now the location of this x-axis we are finding with respect to x, so this distance will become y, so therefore y bar will be equal to half of 200, so this is 100 mm. So we can say that 100 mm distance is same from bottom as well as from top. Now after getting y bar, we even need to know x bar, that is, once we know this distance is y bar from bottom and top, it is clear that centroid will be on this line. Now where will that centroid act? That distance would be called as x bar. So now I'll say that since the location of y-axis for given C section, that location of y-axis is a1 and that distance would be x bar is equal to a1 into x1 plus a2 x2 upon a1 plus a2, and since we have three areas here, what I will do, divide this into three simple rectangles. So rectangle number 1, rectangle second and rectangle third. So plus a3 into x3 and here plus a3. I'll call this as the first equation. Now in x bar y bar I need to know all these values, so area 1 will be 50 into 10, that is 500 mm square. Next x1 is the location of y-axis for rectangle number 1 and that is at half of 50, so x1 is equal to 50 by 2, that is equal to 25 mm. x1 is equal to 25 mm, that is, it was the location of y-axis for rectangle number 1. Then similarly area 2 will be 10 into 180 and x2 will be, it means the y-axis for second rectangle and that is passing at half of 10, so this distance is x2 5 mm. Next, therefore area 3 will be same as area 1 because this is symmetrical I section, symmetrical C section, and x3 value will also be same, their y-axis are passing through the same line, that is at half of 50. So after getting all values here, I can say that putting them in equation number 1, so therefore put all values in equation number 1. So we have here x bar is equal to a1 into x1, a1 is 500 into x1 is 25 plus a2 is 1800, x2 is 5 plus a3 is 500 and x3 is 25 divided by area 1 plus area 2 plus area 3. So if I add all these values and find the answer, x bar comes out to be 12.14 mm. Now this distance which I have got, the reference was from left hand side, so this is from left hand side, the x bar value. Now I can find x bar from right hand side as well, that is from 50 I am going to subtract this value, so 50 minus 12.14, and that gives me the answer as 37.86 mm from right hand side. Now once I have got these values, I can locate it onto the C section. Here this y-axis is located at distance of x bar from left hand side. This is 12.14 mm as we have found out, and from right hand side 37.86 mm. And once we know this location of y-axis, we can say that x and y both the axes are known, and hence we know the location of centroid G. And once this centroid G is known, now we can go for the calculation of MI, that is moment of inertia. So in this, the next step is, since MI, that is moment of inertia, for given C section about x axis, that is given by Ix is equal to Ix1 plus Ix2 plus Ix3. I will keep this as second equation, and now I'll go on for the individual calculations of Ix1, Ix2 and Ix3. So starting from Ix1, what is Ix1? That is MI of rectangle 1 about horizontal x axis of C section, MI of rectangle 1 about horizontal axis of C section, that is given by Ix1 is equal to Ig1 plus area 1 into h1 square. This is by parallel axis theorem. And why we are using parallel axis theorem is that because if we look into the diagram, then the x-axis for rectangle number 1 is here, that is at half of 10, but the x-axis of complete C section is at 100 mm. So there is a gap between these two axes, and this gap is known as h1, and that is why we are using parallel axis theorem. So here I need to calculate the MI for section 1 about the centroidal axis. So here I have written Ig1, therefore Ix1 will be, Ig1 is, since it is about horizontal, so BD cube by 12, the formula for rectangle plus area is B into D. Now what is H1? H1 is the distance between the two axes, so it is 100 minus half of 10. So here I will go on putting the values. Therefore Ix1 will be equal to B and D values. For rectangle number 1, B is 50 and D is 10. So it is 50 into 10 cube by 12 plus area is 500. H1 is 100 minus 5 whole square. So from this I am getting the answer of Ixx1, which comes out to be, it is 86.86 into 10 raised to 3 mm raised to 4. After getting Ixx1, I can say that now Ixx2, it is the mi of rectangle 2 about horizontal centroidal axis, that is x axis of C section. So therefore Ixx2 is equal to Ig2 plus area 2 into H2 square. So here again I am using parallel axis theorem. By parallel axis theorem, but something interesting is to be noted here, that here for rectangle 2, the x-axis of rectangle 2 is at 100 mm distance, and even the x-axis for complete C section, that is also at 100 mm. So there is no distance between the two axes, like previously it was H1 for first rectangle. Now we don't have any distance, so H2 will be 0. So therefore H2 will become 0, since there is no perpendicular distance, no distance between the two axes. So Ixx2 is just Ig2, which is it is BD cube by 12, and here if I see, B is 10 and D is 180, so 10 into 180 cube by 12. So therefore Ixx2, the value is, it comes out to be, so now Ixx2 will be 10 into 180 cube divided by 12. The answer is 4.86 into 10 raised to 6 mm raised to 4. Similarly, I can say that now in this case, the first rectangle and third rectangle, they are having the same dimensions. At the same time, y bar is also same. So it is a hint, like the mi which we have calculated about x-axis for rectangle number 1, same will be the value for rectangle number 3. So I can directly write down that Ixx3 will be equal to Ixx1, because here it is symmetric about x-axis. So therefore Ixx3 will be same as Ixx1, which we had calculated, and Ixx1, it was 86.86 into 10 raised to 3 mm raised to 4. After getting all the values, we can say that put all values in equation number, in equation second, where we have written Ixx1 plus Ixx2 plus Ixx3. So in equation second, therefore Ixx is equal to Ixx1 plus Ixx2 plus Ixx3 . So therefore the answer comes out to be Ixx is equal to 5.03 into 10 raised to 6 mm raised to 4. This will be the first answer for us. then we have to find Iyy. So therefore Mi about y-axis is given by Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. This will be equation number 3 for us. So here therefore Iyy is equal to Mi about centroidal y-axis for rectangle 1. Iyy is Ig1 plus area 1 into h1 square. This is by parallel axis theorem. So therefore Iyy1 will be Ig1 is the Mi for rectangle number 1 about its y-axis, and that will be db cube by 12, the formula for rectangle about y-axis. Area is b into d. Now h1 is, I can directly say that it is 25 minus 12.14, because at 25 the y-axis of rectangle 1 is located and the y-axis for complete section is at 12.14. So this distance is h1, I can say. So this is h1, 25 minus 12.14 square. So here D and B for the rectangle number 1, D is 10, B is 50. So Iyy1, this comes out to be, it is 186.86 into 10 raised to 6 mm raised to 4. And now Iyy2 is the Mi about centroidal y-axis for rectangle second. Therefore Iyy2 is Ig2 plus area 2 into h2 square, again by parallel axis theorem. So therefore Iyy2 is equal to Ig2. Now we can see this from the diagram that the y-axis of rectangle 2 is at distance of half of 10, that is 5 mm, whereas the y-axis for complete section is at 12.14. So it is 12.14. So here that will be solved by parallel axis theorem. Ig2 is db cube by 12, Mi for rectangle number second about its y-axis, plus area 2 is b into d, and h2 is the distance between 12.14 minus this distance, which is 5 mm, because I want the distance here. This is h2. So it is 12.14 minus half of 10 square. So Iyy2 will be D and B values. Here D is 180 and B is 10. So 180 into 10 cube divided by 12 plus 180 into 10, 12.14 minus 5 whole square. So Iyy2, the answer comes out to be 106.76 into 10 raised to 3 mm raised to 4. Now after getting I by 2, I can say that similarly I by 3 is the mi about centroidal y-axis for rectangle 3. So therefore I by 3 will be equal to Ig3 plus area 3 into H3 square. This is again by parallel axis theorem. So therefore I by 3 will be, now here we can see that as the section is symmetric, so the distance of y-axis for rectangle number 3 is at 25 as it was for first. So whatever answers we are getting for rectangle number 1, same will be for rectangle 3. So I can say that I by 3 is equal to I by 1, since symmetric about x-axis. So therefore I by 3 will be equal to I by 1 was 186.86 into 10 raised to 6 mm raised to 4. So after finding all three values, we can put them in equation number 3. So therefore put all values in equation 3. So therefore I by is equal to I by 1 186.86 into 10 raised to 6, I by 2 106.76 into 10 raised to 3, and I by 3 186.86 into 10 raised to 6. After adding all the values, we get I by, and the answer is 373.83 into 10 raised to 6 mm raised to 4. So this is the second answer. As we look into the problem, there were two things asked: calculation of mi about x-axis and about y-axis for channel section. So about x-axis we have found the value 5.03 into 10 raised to 6 mm raised to 4. About y-axis 373.83 into 10 raised to 6 mm raised to 4, and with this we complete the question.